Hello everyone. This is Sanchita, and I hope you all are doing good and staying safe. So I'm Sanchita, and I am program manager with Microsoft, and my team and I basically look into the intelligent insights for real estate within Microsoft, and we see how we can empower the data that we have with the ML and provide some really cool insights. Microsoft Real Estate has around 400 plus offices across 103 countries. And so the data that we deal with is pretty huge. And Let me just share my screen and then we can get started. And I'll probably just switch off my video because of the network issue. Yeah. So today, Manju and I will be talking about how we can leverage ML to gain meaningful insights from the data. And here is the agenda for this session. In this session, we'll first take a look at the business use case. And today we'll be talking about the carbon footprint, how we derived at this, how we leveraged our existing data to get some insights into sustainability. And then we'll take a demo of the report that we created, sustainability report. And after that, we'll have a walkthrough of the ML model for the behind the scenes. So let's just start with the business overview. You have probably heard about the ambitious goal Satya has set about being carbon negative by 2030. And to reach there, we must minimize carbon emissions at each level. And when we heard about it, we looked at the huge real estate data, about millions of rows of that data that we had, and we thought, how can we leverage this data to contribute towards this mission? So that is when we came up with this idea of carbon dashboard. This dashboard would insights into carbon emissions of Microsoft buildings and show the relationship between the attendance and the carbon emissions. This would also provide insights into how what is going to be the future attendance. So we created an attendance prediction model which will tell how many employees are expected at what time for the next 2 weeks. And we believe that this attendance prediction model would help facilities managers to plan better resources such as food and transport, and even heating, ventilating, and air conditioning systems, the optimal time to switch them on and on. And if we plan around those things, then in turn, we can reduce carbon emissions within our own premises. So with this, let's take a quick look at the video to just get the summary of this. So I hope you are able to get a bit of an understanding about what we are trying to achieve here. And I'll just share the demo as well, just so that we get a bit more detailed. Just one second. I hope you can see my screen. Okay. Uh, Yeah, so this is basically the report that we came up with, and here is the carbon dashboard, and it's just a prototype, and the data we have kind of masked up as the intent is just to really show the technical capabilities around it. And in this report, we have three views. The first one is about the executive summary view, where you can glance at the carbon emissions across the globe. We have created a carbon calculation engine to translate the utilities consumption within the Microsoft buildings into corresponding carbon emissions. We'll talk about that in detail later while having a technical session maybe. But for now, let's just concentrate here. We have on top we have certain filters to slice and dice the data that we have, and yeah, I've already filtered it on 2019 to get a better picture over here. Below that, we have certain key metrics such as total emissions and per capita emissions, and which building is actually having the most carbon emissions across the globe. Uh, Below that, here we can see there is a world map view where each bubble represent the carbon emission for that particular building in that area. And after that, we can see how each of the category is contributing towards the carbon emission, electricity and natural gas, and we have year on year trend. And the bottom ones are really interesting because here you can compare how the buildings across the globe are doing based upon their per square foot carbon emissions. So on the x-axis there are building names, and the y-axis you can see the carbon emission per square foot or water consumed per square foot, and similarly the waste generated. We get some cool insights from this tab as well. So for example, if I compare region 1, and the region 1 has total emission of 42 metric ton carbon, and the waste generated, average waste generated per person is 1.24 kg. And if I compare this data with region 2, the total emission is just 30k metric ton, which is less than the region 1. But if you look at the waste generated, it is almost double that of the region 1, right? It's almost 2.2. So looking at these insights, we are planning to have an ML based recommendation engine so that building managers can learn best practices from each other and take appropriate actions for their buildings. And now to get more granular insights from the building, we can look into the next tab, which is the building detail tab. And here we have similar filters and top metric. And now below here you can see a graph which shows the relationship between the carbon emission and the attendance for the last 6 months. The columns are essentially carbon emission, and the red line you are seeing is the attendance. And here you can see the close correlation between the emission and attendance, because as we started working from home since March onwards, there is a dip in the attendance as well as in the carbon emissions as well. Below that, we have a graph which shows the consumption of, which shows the relationship between the total emissions and per capita emission for the selected time frame. And here, the orange line here you can see is the per capita emission, and the bars are total emission. And we have similar graphs below, which shows the correlation between per capita water consumption and per capita waste generated based upon the year on year trend. So the interesting insight that we can derive here is that the per capita, right? There is a very tight correlation of per capita consumption of water and waste uh, with the attendance, like the with the overall emission, overall consumption and waste generation. So this kind of validates our hypothesis that attendance has direct impact on people centric scope 3 emissions such as waste and water, right? So based upon that, when we saw that we have direct impact on how people, based upon the number of people, the water consumption and waste generated is increased, we thought if we can optimize there by providing some ML prediction model that could help us eventually reduce the carbon footprint across the board. So here we came up with the third tab, which is occupancy prediction. Here we are predicting, here at the top, we again have the same filters and then some key metrics. I have filtered it on a particular building, and here if you see, right, the key metrics I would just like to call out is that for the day we are predicting what is going to be the expected head count, which is 85, and then we are saying how many people are expected till lunch, which is 54. So maybe we can plan lunch for 54 people, and evening snacks for 85 people. uh, Next we have a graph which will give expected hourly attendance for next 7 days. We can filter on a particular day using the slicer on the right over here, and here the different color bars represent different time slot, and as we can see the is the most of the folks are coming between 9 a.m. to 10 a.m. So this insight can be leveraged to start heating or air conditioner systems optimally, right, just before we expect folks to come in, instead of starting it every day at a particular static time. The next one gives the overall prediction in the week, how the next week looks like basically, and in the bottom we are doing a comparison between actual versus impact, actual versus what we predicted, and our accuracy is around 85 to 90%. So this is a good business use case of how we have leveraged ML and ML into our existing data set, and I hope you got an idea to how any, or you can use just the power of ML on and get strategic insights on any data source and make some real impact. So with this I would hand it over to our lead engineer Manju to walk through technical details and how we brought this idea to the life. And thanks a lot for listening to me. Over to you, Manju.
Yes. Hey, thank you so much, Sanjita. It is awesome to know how analytical and the ML approach that provides a granular insight into the carbon emission of all Microsoft buildings. Hey, hello everyone. Hope you all are doing good. So I'm Manjunath. I'm a data scientist with my Microsoft. So I will share my screen. Please let me know once you are able to see. Can you able to see my
We,
screen?
yeah, I can see
Yes.
Manju.
Yeah. So next 5 minutes, I will walk through the ML model development and the consumption. That is how ML-based people prediction model, which will predict the time-based attendance, which can be leveraged to save energy, food and fuel, and then in turns to reduce the carbon emissions. So as we know that on the problem statement, the problem statement, that is the how the portfolio manages to track the carbon footprint of their building across various categories such as energy, natural gas, waste, and then waters. So the analytical approach which we use here to solve this particular problem is, that is we divide into two parts. The first In the first part, the analytical approach to provide the granular insight into the carbon emission of all Microsoft building, which is already well covered by Sanjita in the previous slides. The second approach, that is ML based people prediction model, which will predict the time based attendance, which can be leveraged to save energy, food, and then fuel, and then in turn to reduce the carbon emission. The overall impact of this solution is to provide the granular insight into the carbon emission of all Microsoft buildings across various emission categories to empower facility managers to fulfill the Microsoft pledge to be carbon negative by 2030. In addition to this, the facility manager can also use this carbon dashboard to validate that the ML based people prediction model, people based models, the accuracy and how it is performing. So, so talking about ML people prediction models, we are predicting the people count on hourly basis. Using this data for a particular building at particular point of time, we can leverage the amount of usage of resource and other utilities in the offices, which is directly impacts the carbon emission. So I will give some short insight about the models. So we built a ML prediction models to show the prediction of next 7 days at hourly interval categorized by each buildings. So this model also addresses the existing outlier situations such as COVID-19. That is, the training data set can be altered easily based on the prevailing scenarios. Once the office starts functioning, the factor of percentage of employee allowed to visit the office is taken into consideration for better predictions. And once the COVID situation settle down, the data set can be dynamically changed to pre-COVID data for the future accurate predictions. The model which we built, we tested, and then it works in both scenarios like pre-COVID and then post-COVID situations. So finally, we built a dashboard top of ML output, the output, and then we refresh daily so that it can be used by various business users to track the result and performance of ML model and can look at the expected result of the current days and then 7 days from there on. So basically how it works. So majorly we have 5 phases. That is, one is data extractions, data pre-processing, training data preparation, modeling, and then predictions. So we'll discuss one by one. So in the data extraction phase, initially we procure the Wi-Fi sessions data, which is indicates the presence of each device in a building, and each session indicates the information about which devices has been connected to which access point for how long. And we process this data along with the batch wise data recorded by the iconic devices or sensors to get the credible information out of personal levels. And then we use some metadata information or metadata information also, that is start and end date for the training data sets to handle the pre-COVID and the post-COVID scenarios. And then we use that another metadata information, that is number of days that models need to be predicted. So to understand the better data, I have plotted the log and then batch values for 180 first 180 days to understand the behaviors. So if you see that on the x-axis, which indicates the days, and then date, and then the y-axis, which indicates the log on total PHC, and then batch PHC, that one. So if you, based on this data, we can see some observation. That is, the first observation is mostly consistent pattern, and then there is some dips during the non-working days or weekends, and then there is a holiday seasons can be seen overalls. However, we seeing some missing data around the last September and then early January. This can be caused due to some maybe some outage maybe happens. So in addition to uh, obvious patterns, we seen some erroneous days, that is like some days in the June randomly missing partial data. So these are the current raw data that one. So we need to fix this data before we are building the particular model. So how we are fixing this data will be in the next step I will explain you. So next step is that one, data pre-processing. So, so in the data pre-processing, there are the steps 2 and then 3 are most of the similar things. That is, the main goal is to make the data is available for the training the models. Here the majorly we're concentrating on the data cleaning and then data filtering. The data cleaning is nothing but we are doing the data imputation for the missing value per day, and then if it is any incomplete number of days if it is there. So there is in another way that on we are doing the erroneous and then unexpected value we can be removed from remove that one in the data cleaning steps. In the data filtering that one, we want to consider only workday information, so we are excluding all the non-working days information, and then we'll remove that on bad and the inconsistent data also. So here, to handle missing values, as we know that we have two type of data, that is Wi-Fi data, that one, and the HR data. The HR data which indicates the headcount informations. So to handle the missing values in Wi-Fi data, so we are performing the below step. That is, one thing is what we considering is, so any day which has less than 10% of total headcount as a occupancy, I ignore those days, and then we use the existing statistical ML model, which does the data imputation for the bad data. If I see the data model inputting over 100 data points per day, I ignore that day considering it has partial data loss day. So in addition to that one, we'll use we'll remove some outlier also using the Sarima models. So this is with respect to handling the data, handling the missing values in Wi-Fi data, and the same thing for HR data. So comparatively, HR data was easiest to handle as the data is a snapshot of per days, indicating that total number of employees company has on that days. So when I notice any data is missing, I will fill using the previous days data. In graph, you can see that there is some partial data in the few days, and here also, and there is completely data is missing. So in this case, it is using the previous day information. There is output of after data imputations things. So now hope you understand that how we are filling that missing data here. So then this is the high level data pre-processing flow that one. So here we have that one raw data. So here, as we know that one, we are predicting the hourly basis. So we need to prepare that one, prepare that raw data into that hourly occupancy data. So then we'll apply some filters to get only workday information. So and then as I said that we are doing the ML statistical models to model for data inputs to eliminate the incomplete data per days. In the second phase, what we are doing is we are getting the headcount information per building per day from HR data, and then we'll do here also we'll do that on data imputation for missing headcount informations. Once these two phases pre-processing is done, then what we are doing is we are merging both occupancy and the headcount. So then we'll do some filters the data to keep only working hours, and then we'll remove so all the outlier also. Outlier also, and then the output of this data pre-processing is that one, the data set we divide into training and the test data set. So this is the data pre-processing, that is the output of data pre-processing. Once the pre-processing of raw data is completed, we have the information for each building at 1 hourly interval level that one. So you can see that data like, so due to that security concern, we're not showing that actual data that one. So in this one, the output of the data pre-processing is, so the building, the name of the building and the date created, that is local to the building's time zone, and then there is a hour information, that is the each interval hour, that how many log on is happens, and then there is a batch total PSC is indicates the total number of people in the building of this day using the batch swipe informations. That is and then next we have the log on total PSC, that is total number of people in the building using the Wi-Fi and the desktop logins. And then we have we are calculating the each working day information that denotes the day is a work day for that building or not. And then next we have the headcount information, that is denotes the total number of people assigned to that particular building at this time. And then we have that on PHC max. It indicates the hourly interval is the peak occupancy value for that particular days. And then we have that on, as I explained that on we are using data imputation things that on. So the next two column indicates that is batch total PSC prediction and then log on total PSC predictions. That is the output of statistical model which checks the data for the anomalies days or days, and then data drops, and then uses the regressions to impute the data. So in the next one is that modeling thing. So I will go briefly that one with respect to the model which we using those. So here we experimented with, we have done the different experiment where perform using the some algorithm, that is Sarima model, and then as well as the Facebook of Prophet models. After out of comparative study, the time series Sarima model with exogenous hyperparameter was finalized using the RMSS score. So the score compared to all the three models, it was very less. That's the reason we choose Sarima models. So as we know that on Sarima is nothing but a seasonal auto-regressive integrated moving average, or we can also call as a seasonal ARIMA. It is an extension of ARIMA model. Maybe most of the people they will work on that auto ARIMA models. That is the same model. It is extension that is explicitly support the time series data with a seasonal component. The advantages of seasonal model is that it adds the three new hyperparameters to specify the auto regression differencing and the moving average for the seasonal component of the seasons, and then as well as it will add the additional parameter for the period of the seasonality. So here currently we are every 1 hour predicting that on the seasonality will be as a 24 hours. So as we know that on the seasonal ARIMA models is formed by including the additional seasonal term in ARIMA. So the seasonal part of the model consists of the term that are very similar to the non-seasonal component of the model, but they involve the backshift of the seasonal pages. So to configure the SARIMA models, so we need to do the we need to configure that the hyperparameter of the trend element as well as the season element. So that there are the three trend elements that requires the configuration. They are similar to the ARIMA model. That is a small p, q, and then d. The small p stands for the trend auto regression orders, and the d stands for the trend difference order, and then Q indicates the trend moving average orders. So and then we need to configure the season element also. There are 4 seasonal elements that is not part of ARIMA model that must be configured. So which are those is capital P, capital Q, and then capital D, and then small m's. So the capital P, which it indicates the seasonal auto regressive order, and the capital D indicates the seasonal difference order, and then Q, it will be indicates the seasonal moving average orders, and the M indicates the number of time the step for a single seasonal periods. So whatever the value you are seeing here is within brackets, these are the hyperparameters after a number of experiment we finalize it on. So here we are applying the same algorithm for all the India, I think nearly 400 buildings are there. So each buildings behaves differently, because if you see the COVID in the COVID situation only, the operation of the each building will be completely different than other building in the regions. So that's the reasons we have done the n number of experiment, and then we finalize these are the best hyper parameters suitable for the all the cases. So as we know that in the previous slides which we discuss the going to the data being seasons, we are capturing the particular trend, and then also it is depends on a few external variables. So once the hyperparameter tuning everything is done, then we'll do the training of the models. So this is with respect to the Sarima models why we chosen. So this is a completely high level flow of the model. So currently I am in the pre-processing steps. I explained these are the steps, and then in the modeling part that I told, as I told that we experimented with ARIMA model, SARIMA, as well as the Facebook Prophet, and then we have LSTM also, neural network also. I intentionally removed the from the slides because we have next session, the I think afternoon session that we are covering that LSTM things that on. It is very promising result compared to any machine learning algorithm. So first we concentrate on only these 3 algorithms. So here we done that we experimented with this 3 algorithm, and then we check the score of the each model per building level, and then we evaluated that one, the score which is the best model we can be chosen that one. So here is the result of the result of each models, that is ARIMA model, SARIMA, as well as the Facebook profiles. If you see that the output of ARIMA model, that is RMS score, that is root mean square, that is 0.0022. That is very what you call is very accurate kind of thing. If you can see this one, there is very small the actual, and then if you see that red color is actual, and then the blue color which indicates the prediction things. If you compare to any other models, the seasonal ARIMA model will give the best result. That's why you can see that on the RMS score is very less. And the same thing, we capture that mean absolute percentage error also. So the in the SARIMA model is very less compared to both models. So the next step is that a predictions that on. So once the model training is done, that we deploying this particular model as a web services. So that on the model will be enables the users to predict for the any number of days from the current data, which will be useful for the prior planning for any business use cases. So this is with respect to ML model. So we have some couple of applications that on which we are already using in Microsoft. So one is predicting the optimal start time for HVAC system for the building based on the ramp up time predictions, and the time when the occupancy will be 25 percentage. It's nothing but the HVAC system is nothing but the AC control system, ventilation system that on. So instead of switching on that particular HVAC system at a particular time, so first validate that there is any how many employees that it will be coming to that particular time. So based on that one, you can monitor that. And the same thing, you can do the HVAC system stop also. So this prediction not only result in cost saving, but it also helps it reduce the carbon footprint. The second application is starting off all electrical appliance only at a time when a particular occupancy reaches instead of allowing it to run in 24 hours. So this will be tremendously save the electricity at larger scale, and hence the reduce the emission of carbon, which is our primary goals. The third use cases, this can be used in cafeteria and other food utilities to prepare the amount of food based on the expected turnover, so that one you can reduce the wastage of food, and also consumption of fuels, that in turn reduce the carbon emissions. These are the three we have a number of applications, but these are the three major applications which we are using in Microsoft. So I will hand over to Srijan for that model deployment and then consumption. So Srijan.
Yeah. Hi all. This is Srijan. I'm a data scientist with Microsoft, and we work on a lot of machine learning models and projects for EUSE as an organization, which is End User Services Engineering. Now, to cater to all of the machine learning requirements for EUSE, we've built a machine learning platform leveraging all of the Azure tech stack, so that all the machine learning requirements within EUSE are catered to, and and all the ML and DS teams can essentially follow the entire ML lifecycle best practices. So the entire ML platform has mostly four components. The first one is the model deployment and training components, wherein predominantly we use Azure Databricks for performing all the data cleaning and pre-processing steps for preparing data for the model. We develop and train our models in Azure Databricks as well. And once the models are trained, all the trained models and the clean data is essentially stored in the Azure Data Lake Storage Gen 2. So this phase is the model development and training phase. Now, when we talk about deployment and operationalization, we use Azure Data Factory, which essentially helps us in building automation pipelines where starting from data ingestion to execution of the model, everything is automated with the help of Azure Data Factory version 2. And when we talk about operationalizing and deploying the models into production environment, we have automated CI/CD processes, which are continuous integration and continuous deployment pipelines in using Azure DevOps. So this is the second phase where all the deployment and operationalization is essentially realized. Now, the third component is governance and monitoring, where once the models are pushed into production for monitoring purposes, again we use Azure Data Factory to monitor the production jobs, and in an event of failure, the root cause can be isolated through the monitoring in Azure Data Factory itself. Apart from that, we have leveraged application insights to maintain log of the code. So whenever the code is executed in a production environment, application insights essentially maintains the log of the entire code execution. And again, in an event of failure, we can go back to application insights and isolate the root cause of the failure. Now, lastly, when we talk about consumption, most of the ML models would be consumed through Power BI reports or will be exposed through API or web services endpoints. So this is how the entire ML platform has been set up for USE, where the entire ML lifecycle can be realized through all these four broad components. And yeah, this is how we are accelerating all the AI and ML requirements within EUSE.
Yeah, thank you, Srijan. So I think so we are end of this. Yeah, so we have still 5 minutes. So I think if any question is there, so we can take those questions.
Manjunath, we have a couple of questions in the chat. Can you guys take a look at it once?
Yeah, sure.
Yeah.
Yeah. This was the question. Okay. Hi, Manjunath and Sanjita. This yes, has a question says. Okay. So the first question is that how well did the profit model perform as the compared to Max, and then did you explore the LSTM and then RNN algorithm? Yes. So with respect to the LSTM and then RNN things that on, yeah, definitely we explore intentionally we skip that one. So we already have I think afternoon sessions. So we are explaining the LSTM and then RNN things that on. There is the best compared to machine learning model. What else we explained? Max, AutoRima, and then Facebook profiles. The LSTM will give the best results. So currently, why you chosen the Max is that one. So we whatever the training we have done the data is only for COVID situations. So in the COVID situation, with the amount of data is very less that one, so we don't want to put the more computation powers, and then the accuracy is also very good in Sarima models. That's the reason we went for Sarima model. But in the productionize, so we are going the LSTMs. That is already we explored, and the result is also there. I think maybe in next sessions we will get to know that what is actually the LSTM, how it will work. I think hope I answered your question, Aditya.
Yes, Manjuna. Thanks.
Yep. I think there is no other question if I'm not wrong.
So there's done one question on the model, Manjuna. So the question is, does this model consider
Yes.
factors like weather conditions, patterns?
Yes, obviously, yeah. That one we are we'll do in the post processing technique that one. So here I skip that post processing technique that is due to the time constraints. After we get that information, we're considering the weather forecasting also that one for the prediction things that one. Yeah, yes, we are considering that one. Yeah, and then definitely it is impacting that attendance. Because if you see that in Puget Sound area and then US things are some of the winter season and then the way of employees coming to the particular times is definitely very than the more normal scenarios. So whether if you compare with the actual result of the Sarima model and then if you add weather forecast is also a part of that one, it definitely has a huge variations. Yeah, but this model is also that the post processing technique we added weather forecasting and then based on that only the prediction is happening. I think I hope. Yep.
I think, yeah, that covers all the questions right now, at least we have in the chat. Does anyone have any questions? Maybe you can come out of the mute and ask before we move on to the next session. Okay, there's
As
one
it
more.
was mentioned, okay, so there is one more question. As it was mentioned that this method achieve 85% accuracy, how these models can help us to achieve 100%. Yes, we have the few criteria that one. So what was the when you're doing the seasonality that one. So we need to validate the what kind of data we have that on the seasonal data that is the history data which we are using for training that models. If you say the COVID situations, I will take example for the COVID situation where the model is only 85 to 95 percentage. In the COVID situation, some of the regions, so they are allowing if you go for the Chinas, they are allowing employees to come into the office. But if you see that in India, there is not like that one. So because of the seasonal data, we have missing few things, and then we are not using same each one on model for one on buildings that one. So because if you see that there is 400 buildings are there, we can't develop a 400 a model for that one. So this is a generic models which we build for each building. So in some buildings it will be the 85 to 90 percentage, and then some building it has 100 percentage. But if you have the proper data for that particular buildings, it's completely dependent upon
But
the data set.
Manjunath, one question from my side.
Yep.
Is it practical to even target 100%?
Practically no. It is any ML or any deep learning model.
We
So
shouldn't, right?
you shouldn't. You shouldn't. You shouldn't. Because I will give one practical example which I was working in the previously in Samsung R&D. So there we'll target 99.7 for we are completely well doing that image processing that one. So that is a target line that one. But some cases if you have wrong data, so you can't predict. The model can be in the productionized. It can be go to 30%, 10%. But it's completely depend on how the data will be there, the training data, how accurate.
Yeah.
But 100% is practically it is not possible. Yeah.
Yeah. So just I want to add one point here.
Sure,
So
sure.
most of
Yeah.
us know, but when we are doing AIML, we don't target for the most accurate answer. We target for the best possible answer.
Yes.
So
Yes.
it's like any critical models we target anywhere between above, life sciences or any mission critical scenarios you would target 95, 98. But if your model is doing 100%, then it is proven that it's not going to
It,
work perfectly in the real world.
yeah, it will be the
So,
overfitting models, if
yeah.
I'm not wrong. Yeah.
All right. So then, if there are any no questions, probably I think we have our next speaker is ready. So thanks, Sanchita. Thanks, Manjunath, and thanks, Srijan. So we'll move on to the next session.
Yeah. Thank you all.
All right.
Thank you.
Thanks, guys. All right, Aditya,
Thank
over
you.
to you. Hey, Aditya, can you
Yep,
hear
sure.
us?
Yes, I'll start sharing my screen. Let me know when everyone's able to see it.
Yep, we can see it.
All right, great. So hello, everyone. I'm going to take this next session on accelerating data science and machine learning workflow using Azure machine learning. So as we saw even in the last session, in order to uh, deploy a completely end-to-end data science or machine learning workflow, a lot of work is initially required on the software engineering part, on the data engineering part, then setting up all the resources. So it is quite time consuming. So how exactly can we accelerate this entire workflow, and whatever the specific elements of setting up an enterprise level data science and machine learning workflow, how do we exactly bring it under one umbrella? So that is where Azure machine learning kind of helps us a lot. So I'll start with the session, but before that I'll give a quick introduction about myself. So I'm currently leading the data science and the AI team at West Pharmaceuticals. And previously, I did work in Microsoft, and I'm really kind of well seasoned in domains such as machine learning, deep learning, IoT, robotics, as well as cloud computing. Particularly in the data science domain, I do have good experience in computer vision, time series forecasting, natural language processing, and with speech analysis. But apart from my day job, I do work in research projects, particularly related to AI, data science, deep learning, and even cognitive computing. And I'm part of a, NGO called Must Research, and I'm also one of the faculty members at Must Research Academy. So, in case if any one of you is interested to know what I'm doing or get connected to me, you can reach out to me through my website or even through LinkedIn, and I'll be very happy to get connected. Now, before we get started, I just wanted to mention the topics that we are going to discuss. So first of all, I'm going to give a quick overview of how a enterprise data science and machine learning workflow should be like, and then how Azure Machine Learning Studio can provide a 360-degree workspace for completing or connecting all the various discrete dots in this entire flow of a machine learning solution. And at the same time, Azure Machine Learning came up with Python SDKs so that we can build our own custom machine learning pipelines in order to accelerate the entire process. And like other Azure services, which I really like about, Azure Machine Learning also provides good integration with the various other services provided under the Azure platform. So with this, we'll get started. Uh, just to give a brief context, I'm quite sure that most of you have heard about the Industry 4.0 expectations. But just to bring these expectations and trying to map with the expectations over AI and machine learning. So basically, all the different segments, would be kind of driven by data-driven approaches. So it can be your various workflows, various systems, and everything has to be made as a smarter version of what we see right now. But in order to do that, uh, initially, again, like this is quite common, but initially a lot of advanced research has to be conducted so that we identify where exactly the state of the art solutions can be applied. But the main problem is, and in fact I was it's quite common, and people really think about this, that the research that the advancement in research that happens, and whatever we get or leverage at the current industry, there is a huge gap. So how do we exactly fill the gap between advanced research and leverage the benefits of these technologies in a sustainable and scalable manner? And the last one is the reason why artificial intelligence and machine learning is gaining popularity. One of the main reason is to reduce human bias or human errors as much as possible, and to automate things that is difficult to do, or maybe that is quite cumbersome, or that requires a lot of human effort, and because of which human error can come into picture. So based on that, we are going to look at how a scalable and sustainable machine learning workflow should look like. So typically, this is how the enterprise ML workflow should be like. So everything has to be again pluggable, and there has to be like a good amount of modularity in the entire solution flow. So there has to be a data layer using which or from which the data would be flowing through. the main machine learning engines or the algorithms that would be running, it would be on the analytics layer. And even in the previous session that we saw, that the results of this of the machine learning models has to be consumed in an end application, so which we are calling it as the user interface layer. And the way it is usually consumed is through a middleware API layer. Now, if you guys are aware of, like, most of the machine learning models are built may not be that much accurate. Even we were having that discussion before. So in order to improve the machine learning models in a more incremental way, we need to have something like a monitoring and a feedback layer. So basically, the monitoring layer would be used to see whether, like, how well the models are performing, and if the models are not performing well, then what exactly do we do? Do we train it with more data? Do we try to capture maybe data from different sources, diversify the entire solution? So for that, we need to have that feedback layer. Now, uh, before even moving on to how Azure machine learning can help, I just wanted to highlight some typical challenges that a data scientist might face in such a production level solution. So as I mentioned, that we need to, the machine learning layer needs to get the data continuously from the data layer. So there has to be certain data pipelines that would enable the continuous flow of data. And at the same time, there are like strong infrastructural needs. Like, it has to provide some computational infrastructure to process large volumes of flowing data. And typically, if we look from a data scientist point of view, data scientists are actually not that much equipped in setting up such infrastructural needs. And at the same time, since there is no perfect model, and the first model may not work at all, so that is why there has to be an approach of rapid prototyping, which means that we need to build multiple versions of the model. We need to experiment with a lot of algorithms. We need to maybe fine tune it with various kind of hyperparameter tuning, which is like often quite popular in the data science world, which means like tuning your models to fit that particular problem, so as to get accurate and good versions of the results. And at the same time, once we have a good baseline model and which is working properly, we need to version the model, so that later, if we want to improve the model, we need to have another version so that we can compare both the version and select which one is working best. And at the same time, as I was mentioning, the whenever the model goes into production, it needs continuous monitoring and retraining so as to improve it in iteration. And finally, as I said, in order to consume the results from the model, there has to be some kind of an API layer that would be fetching the results from the machine learning engine, and using which the end software application can actually consume it. So if we see all these challenges from a data scientist point of view, a data scientist might not be well equipped with meeting all the of the the software engineering needs, or maybe the infrastructural needs. So that is why we need something which would accelerate the entire process, so that a typical machine learning workflow, which might take, let's say, 7 days, can be done as quickly as within few hours. So that is where Azure machine learning comes into picture. And after this, we are going to take a quick walkthrough from the portal, but just to list out some of the key benefits that I felt Azure machine learning provides is, as I was again mentioning, that initially we might need to research with a lot of models. So for that quick research, Azure machine learning provides a Jupyter notebook interface. And then next, we would be seeing about AutoML feature from Azure machine learning. And when I would be giving the walkthrough from the portal, I would be explaining what AutoML is and how it helps again. And at the same time, Azure machine learning provides a nice designer view. So if someone doesn't need to code their baseline model just to get a feel of how the data is, they can easily leverage the designer view from Azure machine learning, where they would just need to form the code blocks properly and just connect everything, and the entire solution can be run within few minutes. And at the same time, whenever we were mentioning about the model versioning or the model registration process, at the same time, we need a data registration process. Because let's say if we train a particular model with some version of the data, and if we again want to train another model with another version of the data, so if the data, let's say, if it is not consistent, and if the distribution of the data is not proper, then the model results won't also be same. So in that case, it won't be an apple to apple comparison. So for that use case, it is always better to have a versioning for the data that has been used as well. And that is where the data registry or the data catalog feature that Azure Machine Learning Studio provides is extremely essential. And at the same time, we were mentioning about the model deployment process. So let's say if I have trained my model and I have a trained model available, so what's next? How do I sure move the model into a production process? So that is where model deployment as a web service from Azure Machine Learning helps to accelerate. And at the same time, in order to meet the computational needs, the different computational infrastructures can directly be created through Azure Machine Learning, or even if someone has their own computational environment, that can also be linked very easily with Azure Machine Learning. So with that, we would take a quick walkthrough of Azure Machine Learning from the Azure portal. So in order to create a Azure machine learning workspace, we can directly create from the Azure portal. So we can just create that particular resource, and once it is done, we can actually launch the studio from here, from the Azure platform. So if I go over here, so this is how the initial starting of the Azure Machine Learning Studio looks like. And as we were mentioning about the various features from Azure Machine Learning, so these are the very top and very helpful and useful features which Azure Machine Learning Studio provides. Now, for building quick models or researching with any code, the features like notebooks, which essentially open a Jupyter notebook using which we can run our Python codes or maybe R codes. And at the same time, it provides a nice feature about automated ML, which is the auto ML feature that I was talking about. And at the same time, it is the designer view using which we can just connect the blocks and complete an end-to-end solution. So with this, maybe we would start with some of these features first, and then we will take a look at the other features that we mentioned about. Now, let me open the notebook from here. So if I go to the notebook section, typically, okay, let me maybe open from here directly so that I keep this tab open. So okay, I think it got signed off. Anyways, maybe let me try from here. All right. So here, if we see, once we open the notebook section, okay, I think I opened it for a long time and it got signed off. Let me get started once again. So yeah, so once we are here, we can go to the notebook sections. So if I have my own notebook, I can definitely open a file like this, or I'm for this particular session, I'm going to show a quick demo from the sample notebooks that are provided. And again, this Azure ML Studio comes up with nice set of tutorials that can be easily followed to kind of replicate what I've been seeing right now. So let's say if we want to take a look at the some of the tutorials that is provided, let's say I want to see maybe something like a image classification notebook. So here, if I go here, so this tutorials would actually give a good detailed explanation of how to implement this. But in case if I want to run this one, I can clone this notebook to my environment. And once that is cloned, I just have to attach to a compute resources. So here, if we see, show you the compute resources, there are like 4 different kinds of compute resources. The one that would be using the notebooks or notebooks to run basically the Python code or the R scripts. It uses this compute instance resource. So here we need to just create a virtual machine, or in case if we have our own, we can also attach to this and run our Jupyter notebooks through here. And at the same time, another good feature of Azure Machine Learning is, let's say if I have multiple data scientists working under the same workspace, the process of sharing notebooks is also very easy. So we would be able to see like whoever has been working on the notebook or whatever progress that has been done, so that if someone wants to build upon or continue upon that work, that can be easily done. Now, having said that, I would move to the auto ML feature, the automated ML. Now, as a data scientist, I'm actually not a very good fan of the auto ML part. But the thing is, auto ML actually creates a very easy workspace using which we can kind of accelerate the process of building a baseline model. So whatever the auto ML version of the models that are provided, the results might not be exactly most accurate or very good, but at the same time it gives us a very good baseline to compete with. So here I have already trained AutoML a small data set that I had, and using which I saw that it was able to experiment with different set of models, with different set of pre-processing techniques, as we see. And at the same time, it would list out the various, the accuracy of the particular model, or any sampling amount that it did, then the duration that it has done. And at the same time, these metrics can also be changed. So let's maybe take a look at how easily we can create an AutoML pipeline or the flow. Okay, so let's say if I have a data set which is already created. So this is one of the heart disease data set which I was able to get from UCI's open repositories. And once the data set is already created and registered, for creating an entire end-to-end AutoML run, I would just need to select this particular data set. And once I go next, it would ask me to either select an existing experiment. So let's say if I want to show this one. And at the same time, as we all might know that whenever I'm trying to run something like a supervised machine learning problem, I would need the true values against which I will be comparing with. So here we need to select the target variable, which would be our true values for the comparison. So let's say we included the target column. And at the same time, as I said, we can either create a new compute resource, but if we already have one, we can just attach this resource and then go next. And based on the type of problem that we need to solve, we can easily select the particular type of problem. And let's say if I want to see additional configuration, for example, if I want to change the base metric which would be used for evaluating the model, I can change it from accuracy to any one of these, like AUC ROC score or any average precision score if we want. Or let's say since this Azure AutoML would try to run across or iterate across different versions of algorithms, right? So if I know that some of the algorithms might not work, then I can just select this, and this will be added as a blocked algorithm, which means that the AutoML flow would not include this particular algorithm and would try to include the other version. So that if we know that which will be working best for this particular data set, we can reduce the time for running a entire AutoML flow. Okay. At the same time, we can set certain exit criteria, which means that if we want our model to run for some limited time, so that if it doesn't exceed a particular, a score, or if it doesn't converges within a particular time, then we can fix the exit criteria over here. And at the same time, we can set the validation type or any kind of concurrency if we want. So creating a model is very easy. So I would just show you from the one that I have already created again. So let's say if we see this this set of scores from here, and out of which, let's say I might know that the first algorithm might overfit on the data. Basically, it might be overtuned on the training data. And so that for a new unknown set of data, that algorithm might not perform. So in that case, I don't necessarily have to select the best performing model, but I can just select the one after that, or any one of these algorithms typically, and I can simply deploy this. So when I said deploying a model, so basically it would first create the pipelines under it. So this pipeline is nothing but step-by-step process which is required to move this particular the AutoML flow to a production system. So once the pipelines are created, it usually registers the model. So now I have a model version for the AutoML model. And in case if I want to, let's say, maybe retrain the model, or add more data and then again fine tune the model, then it would create another version of it. And let's say if I know that which version is would work well, or let's say if the first version worked better than the second one, then I can just select that one and deploy it basically. And finally, once it is registered and once it is deployed, it creates a REST API endpoint, and we can basically consume the REST API endpoint and integrate with any UI application. So basically, consumption is also very easy. It would give the exact URL that is required, and finally, it can be integrated with any user interface application, like it can be Power BI dashboards or anything else, basically. So typically, we can see that how easy the entire workflow becomes right now. Like otherwise, a data scientist would have to be worried about basically first of all monitoring whatever that is happening in the production, and at the same time, even before moving to production, to be honest, there has to be maybe some specialized group of people working to create the necessary set of endpoints that would help in consumption of this model. So typically, whatever workflow that we have seen so far, the entire thing can be done within few hours. Okay. Now let me talk about maybe the designer view. So another good feature of Azure machine learning, which I felt, is the designer view. So in order to maybe code a complete machine learning solution from scratch, it might take some time, right? So in order to prevent that, we can just select the required set of blocks, maybe drag and drop over here, and based on that, we can run the various steps that we usually do as these kind of coding blocks. So basically, if I want to select my data set, I can create the data set. If I want to select any specific columns related to it, or maybe do some pre-processing or feature engineering, even that can be done. And at the same time, if I have, let's say, any kind of custom function that I'm using in the process of feature engineering or pre-processing, I can include that in my Python script. And using that, it can be easily used to transform the model. And at the same time, as we see over here, once we apply the particular algorithm, we can basically divide the algorithm and then basically score it, and even the results that we see over here can be fetched as a web service output. So that this is the particular one that is creating those REST API endpoints. So this designer view is pretty good. We can add the data set, and we can do any kind of data transformation if required. And at the same time, let's say any particular algorithm, and even the advanced one, like I was quite amazed to see that Microsoft does include the smart algorithm. So whenever, let's say, if the data set is not balanced, and for classification problem for unbalanced data set, the majority class might always have a natural bias. So the model would be always kind of prone to predicting the majority class. So in that case, algorithms like smart, which is a synthetic minority upsampling technique, helps to balance the data set, and basically the model results will be much reliable and robust. So I'm quite amazed to see that these algorithms are also integrated and included as a part of the designer view features. And at the same time, like, it is not always restricted only to Python. Like I see like a lot of options from for executing R scripts as well. And even it is not restricted to only structural data set. If someone wants to run a text analytics, or maybe something like a computer vision or an image processing algorithm, so these features are also there as a part of the designer view. And even more complicated deep learning models like DenseNet, ResNet are also provided as a part of the designer view. Now, coming to the kind of the features that really impressed me was this data set, or the process of creating a data registry. As I said, that if I want to register different versions of the data, I can actually register the data sets like this. And later I can use this data set for building my pipelines, or even through the designer view I can use it. In the experiment section, like as we saw, that one was using the AutoML flow and the other was using the designer flow. So it creates as a experiment, so that later if it needs to be monitored and see that whichever has been used the maximum number of times, so these things can be easily tracked. And finally, we did take a look at the model registration and the endpoint part. Let me maybe mention about the data labeling part as well, because I felt that this is quite interesting. So whenever we work for certain deep learning problems related to images, most of the time, if we are working for something like an instance segmentation problem, or maybe something like a supervised classification problem, it requires annotated data basically. So basically, the images that we would be using, it has to be labeled. Now it can be of two types. So when we are doing something like a object recognition, or a bounding box detection problem, so basically the object of interest has to be marked with a bounding box. Okay. So these kind of processes are very expensive, and when we actually work in an end-to-end data science solution, there are times when the data scientist would have to initially spend a lot of time in manually labeling the data, or maybe just getting the bounding box coordinates from the data, and then which would be used for finally the model training part. So those I would say difficult or manual effort can be easily reduced using Azure machine learning. So I would still say that it is there are like few more features which are coming in, but it is quite powerful, and the stage what it is right now, it is quite helpful for the entire data science community to move any research problem or solution to a problem into production in a very short time. Okay. So that's mostly it. I would quickly go back to my slide deck to cover some remaining part. Yes. So the next one that I wanted to cover was building our own custom machine learning pipelines using Azure Machine Learning SDK. Now, whatever we have seen so far, the various options that are available in the Azure Machine Learning Studio, we can also build our own custom versions of it, and we can have our own set of platform that can perform the same set of work. Maybe with it might have integration with some other features if required, but the same can also be developed right from scratch using the Python SDKs. Now, before going into the specific details, I wanted to mention two main types of production data science workflows that can happen from a very high level. So one can be related to online model flow, which means that if I have a live flowing data and if I want to retrain my model online, basically on the fly, and then get the results immediately. In that case, an online model flow, which is very effective and useful. And the second one is an offline model flow. So which basically means I am doing the model training part offline. So I know that my data is static, it will never change. And using that, I would build a trained version of the model. And when I have the trained version of the model, I would just need to deploy that particular model so that I can do live or real time inference. So that is the case in which we can leverage the use of a offline model flow. Now, in order to explain more, so in the offline model flow, as I said, it would be like offline training. Like we know that the data is static, but the deployment or the inference part that would happen, it would be in real time. And for that, we would see this kind of a flow in which the data preparation, the data training, the packaging of the model, and even validation of the model can happen completely offline. So basically, we are not using or leveraging Azure machine learning for the initial, data preparation, transformation, or feature engineering, or training the model part, basically. But once we have the trained model, we can just upload the model into Azure Machine Learning and deploy it and register the particular model. So once the model registering is done, it can be easily versioned as well through Azure Machine Learning. And finally, as we were seeing, once the model is there, we can just deploy the model. So it would build the entire deployment pipeline, and it would create the necessary set of REST API endpoints for the real-time inference part. So once we have the necessary REST API endpoint, we can just simply, integrate with any user application where we can leverage the benefits of the model. Now, the second one is about an online model flow. So in an online model flow, as I said, the training would also have to be online, on real time, basically. And even the deployment has to be on a real time basis. Now, why would we go for an online model flow? So the main reason why an online model flow might be required when the data that is used for training is quite dynamic, when the data is being captured on the real time, and the historical data for that particular use case might not be either reliable or may not have a similar set of distribution across. So that is why a dynamic training model is very much useful, so that basically once the trained model is available online, the inference can also be done easily, and at the same time the deployment and the real-time consumption and monitoring part can also be easily done. So basically in this workflow, what we see is that maybe the initial part where the data preparation happens can be done by the user application, but the other stages like training, packaging, validation, and deployment can happen completely leveraging Azure machine learning. And once that is done, and once the REST API endpoints are received, it can be integrated with again an end user application for maybe monitoring the model or monitoring the results of the model. So this is a very useful part in which if the particular use case doesn't require any specialized attention from the data science team, or I would say doesn't require a continuous specialized attention from the data science team, this kind of an auto-tuned and an online model flow would be really helpful. So the same set of pipelines, the custom pipelines that I was talking about, can actually be implemented using Azure Machine Learning SDK. So the process of even creating the data set, training the data set, packaging the models, then even deploying the models, and even getting the model endpoints can be done using that SDK, and it can be a custom version of what we see in the Azure Machine Learning portal. So typically this would how it look like. The user application would have an interaction layer, which is mostly the REST API layer, and using the, so that basically the REST API layer would be calling those custom machine learning pipelines, which would be again going back to Azure machine learning to use as the platform in which these operations can be done. And finally, again, whatever the results that are required can be relayed back to the user application using the REST API endpoint. So that's about the custom SDK part, which is quite a very useful feature. But another good feature about all Azure services, in fact, is providing that smooth integration with other Azure services. So we see that Azure machine learning can be easily integrated with some of these popular services like ML Flow, Azure Monitor, maybe getting the live data from something like an Event Grid or SendGrid, and at the same time getting data from SQL Server, and running instances on top of Kubernetes, or maybe doing experimentation using Databricks cluster or Databricks notebooks. So these things can be done. And finally, for maintaining the CI/CD part of it, it can be also easily integrated with Azure DevOps, so that even let's say the process of deploying a new version of the model, or integrating with some changes that has been done in the backend, can be easily automated. So that's mostly it. In order to summarize the entire thing, we talked about the initial part where we talked about the enterprise data science and machine learning workflow, and how Azure Machine Learning Studio can come into the picture for building a 360-degree workspace, and whatever whatever effort that is required to build that production level workflow can be really minimized. Like if something that takes 7 days can be reduced in a very short time, maybe 2 hours or 3 hours. So it can be really accelerated to a great extent. And at the same time, we do not have to be dependent on whatever options that is provided only in the Azure Machine Learning Studio. We can build our own custom machine learning pipelines that can perform the same thing, keeping Azure Machine Learning Platform as the backend. And at the same time, if we want to integrate with other services from Azure, that can also be done very easily. So a completely scalable and sustainable machine learning solution can be built. So that's mostly it from my side. And in case if whatever I have said was difficult for anyone to understand, no worries. I can take questions right now. Or in case if we don't have that much time, you can shoot me an email, or we can get connected over in LinkedIn, and maybe we can discuss more on this. So that's mostly it from my side. I can open the floor for questions. Thank you. Okay, I can see one question. Features that enables developers with limited machine learning expertise to train high quality models. How about the computational resources needed for this model than usual? And how AutoML models are powerful that can fit into edge devices, scalable to AI and edge? That's a really good question, Afrit. So for your first question about how about the computational resources that are needed, as I was mentioning that in through Azure Machine Learning Studio, directly either we can create computational resources, like we can create certain VMs, and even it can be like GPU virtual machines required for certain deep learning applications that can also be created from Azure Machine Learning Studio. And connecting those compute resources to a machine learning workflow is also very easy. It's just just need to select that, and based on that it connects those compute resources. So basically from the infrastructural point of view, data scientists would have to just click few buttons and get it created, or even the same can be created using the Python SDKs that are provided. Now coming to your question about how about no also AutoML models are powerful, can that can be fit into edge devices. Okay, so for edge devices, if you are talking about only the live inference part, and if that particular edge device has the capability of connecting to maybe internet and maybe make REST API calls, then in that case definitely it can be done, because it just needs to make those REST API calls. But if you're talking about, let's say, just the model deployment part, then the edge device would have to be connected to let's say can be easily connected to something, let's say maybe like Azure DevOps, using which we can push the latest version of the model into the device. And once the trained version of the model is available in the device, then the model inference part can be easily done. But that's a good question. Okay. I see another question. Can you let us know one use case where I use online model flow? Yes. So one good example in which online model flow can be useful, it will be actually, in edge devices. Let's say in certain IoT use cases where we want to do something like maybe a real-time forecasting based on the data. So in most IoT use cases, the IoT devices might not be able to capture a good amount of data because the storage or the memory the memory resources are quite constrained. So so for that reason, uh, based on the continuous flowing data, or maybe keeping a small time window, if a new version of the model has to be trained online, and based on that we need to get the results, and based on the forecasted result, let's say we want to do or we want to take any kind of rule based action. So in such use cases, when the volume of the flowing data is quite dynamic, but at the same time is quite limited, an online model flow is very much useful and helpful. So it would help us to make that real time prediction, especially when the data is quite dynamic, and the historical data is not that much reliable, and instantaneous action needs to be taken. Okay.
Okay, so is there any additional questions, guys? So if there are any, either post it in the chat or you can come out of the mute if you wanna directly ask Aditya. Okay, maybe just like for a couple of seconds, Aditya. So
Yep,
or we
sure,
can
sure.
move on
Yeah,
to the next session.
sure. You maybe stop sharing now.
Okay, we don't see any questions. So thanks, Aditya. That's a wonderful session.
Yep, thank you so much.
So that gives us a lot of overview on how to use, how to do the ML with a complete, CI/CD workflow.
All right, thank you so much.
Yeah.
Thank you.
All right. Thanks. So probably we can move on to our next session. So I'll invite our next speakers again, Manjunath and Srijan.
Yeah. Yeah. Thank you, Shravan.
Welcome
Sure.
back, Manjunath.
Yep. Srijan wants to take over.
Yeah, sure. Definitely. Yeah, so thanks a lot, Aditya, for that wonderful session. It was really insightful and helpful. Now, the next topic which we want to talk about is a couple of projects which we have worked for global support. So just to give a quick context on what exactly global support is. So global support is a part of the end user service engineering, providing support services to Microsoft internal users, which are essentially the employees. Now, support services span across providing support with respect to applications or any issue with respect to the device or any access related issues, device configuration management, real estate and facilities, so on and so forth. So, given the current COVID scenario and all the folks working remotely, the role of global support becomes ever more important, and it's really important to enable the service engineers and the agents working to resolve the issues of the user, and make their lives much more easier, owing to the fact that folks have started working remotely, and they are bound to face a lot of issues. So, a couple of projects which we have worked on for global support, which we would like to talk about today and give a quick walkthrough. So firstly, we have created an anomaly detection framework, And the second is an automated category and subcategory prediction model, which uses a deep learning technique. So to start off with, the first POC or proof of concept which we have worked on is trend identification and anomaly detection, where the overall objective of this particular proof of concept was to identify the trending issues with on the basis of the volume of generated for a specific category or a subcategory of ticket. Now, when I say category and subcategory of a ticket, whenever an incident or a ticket is raised by raised by an employee, that particular ticket is assigned a specific category or a subcategory. Which what I mean by that is that whether the issue pertains to any access related issues, or whether the issue pertains to any device configuration issue, or is the user facing any VPN related issues. So that is something which is captured in the form of a category and a subcategory. Now again, talking about the overall objective, as I mentioned earlier, it's all about quickly identifying the trending issues, and through in the form of an anomaly detection framework, which essentially enables the global support PMs and service engineers to quickly identify the trending issues and take corrective actions to resolve such trending issues as soon as possible, and ultimately reducing time to resolution for the end user. Now, talking about the current scenario, so currently there's the trends are identified on a monthly basis through manual intervention. There is no concrete business intelligence view or a dashboard which is available for the PMs to have a look at. What are the how are the issues trending over time? What categories are seeing a surge in terms of the volume of tickets being generated? So this ultimately results in delay in time to resolution, and instead of actions being proactive, they are more reactive in nature. Now ultimately the team wanted to improve the methodology to identify the trending issues and reduce the time taken to resolve such issues. Now the analytical approach which we have followed here is something called an STL decomposition statistical technique, which stands for seasonal and trend decomposition through local regression. So this framework essentially identifies anomalies in terms of the volume of ticket being generated at a daily level for each category and subcategory. Now, talking about the overall impact, now, as I mentioned earlier, it ultimately results in increased velocity at which the issues and their root causes can be identified, which ultimately enables the PMs and service engineers for faster problem management. Now, on the basis of the trends which have been previously identified, it can act as a learning ground so that proactive steps can be taken in the future to avoid inflow of such tickets. So for example, if an update was rolled out for a specific application, and because of that update or a patch update, there were a lot of failures or issues which the users were facing. Now, since this has been the service engineers or the respective product team can take corrective actions to avoid such scenarios in the future. Now, lastly, as an expansion to the current POC, we have in pipeline to evolve this particular solution into a predictive model where it can predict anomalies which might happen in the near future, what could be the trend, what could be the factors which could drive such issues or trends in the future. Now, when we talk about the actual methodology which we have employed for anomaly detection, as I've mentioned earlier, we have used a statistical technique called STL decomposition through local regression to detect anomalies in terms of the volume of incidents being created for each category and subcategory. Now, to start off with the first component, we start with the actual data, which is the input time series signal of the volume of ticket being generated for each category. So this becomes the input time series signal for the model. Now, this input time series signal is then decomposed into three components. Now, the first component is the trend component, which gives an overall idea or a general direction in which the overall data is headed towards over a large period of time. And again, this is something which is a predictable behavior and which is observed over a large period of time. The next component in which the original time series data is decomposed into is the seasonal component. Now, again, a seasonal component is a predictable pattern which recurs at a fixed interval. So, in our case, the natural cycle of seasonality is week over week, where during weekdays, number of tickets being generated are higher, whereas in weekends there are dips in terms of the volume of tickets being generated. So the last component in which the original time series signal is decomposed into is the residual component. Now, residual component is actually our point of interest, where it is actually the random fluctuation which is unpredictable, and it cannot be essentially guessed beforehand. Now we deep dive into the residual component, where we perform a round of outlier detection on top of it, where we employ the 3 sigma rule, which essentially states that if a data set is normally distributed, uh, if a data set is normally distributed, most of the data points lie within three times the standard deviation, which is 99.7% of the data points would lie under 3 times of standard deviation. So we take the 3 times of standard deviation as the boundary condition, and whatever residual data points which lie beyond these boundary conditions, that specific data point is essentially considered as an anomaly. Now, why STL decomposition in the first place? So since right now our analysis is restricted to a univariate analysis, where we are just considering the volume of tickets being generated for each category and subcategory. STL decomposition, helps us not only detect global outliers in terms of how many tickets are being generated, but it can also tell us deviations from the seasonal behavior, where I can tell that in a Monday or a Tuesday, the number of tickets being generated are X, but on a specific week, the number of tickets being generated on a Monday were specifically high. So this is a deviation from the usual seasonal behavior, and it can really tell us that something has gone wrong. For a specific category, the number of tickets being generated are exceptionally high. So the agents and service engineers should probably look into the incidents being created under this category. So as I mentioned, since it's able to detect deviations from the seasonal behavior, it can help us uncovering hidden anomalies as well, which would have otherwise remained undetected. Now, talking about the reporting layer, again, we have created a Power BI dashboard, which essentially has two views. The first one is the data exploration and business intelligence view, which gives an executive summary of the overall data. In terms of how many tickets were created for a category or a subcategory, what is the trend over time, and it's really helpful in generating quick insights, and targeted insights can be gained by slicing the visuals based on a lot of dimensions, including the persona of the users as well. So what all tickets the software engineers are raising, what all tickets PMs are raising, what all tickets sales executives are raising. Now, this next view which we have is the actual anomaly detection view, where along with the original time series signal, we have the anomalous data points highlighted as well. And in this view itself, we have a drill down view where the original time series signal can be visualized across the 3 components once it is decomposed, which is the trend component, the seasonal component, and the residual component. Now the entire model has been productionized in the ML platform, which I gave a walkthrough in the first session itself. And the model in production is already powering the dashboard, and it's already being consumed by the business stakeholders to drive insights. Now, to give a quick walkthrough of the dashboard. So here is the dashboard which we have created. And as you can see, this is the business intelligence view, where we have basic KPIs in terms of how many tickets were created, how many users created the tickets, how many categories we have, how many subcategories we have. Then we have the distribution of tickets across categories. So for example, these are the categories under which the tickets are tagged under, application and service, and query help, infrastructure, client device. And for each category, we have granular subcategories as well, which are mapped back to the original category. So we have the distribution of subcategories as well. And then here, we can look into the distribution of tickets across the users persona, where we talk about that these are the organizations within Microsoft, and users from and how many users from each organization are raising tickets under global support. The same thing applies here in profession, where out of all of the tickets being raised, how many of what is the percentage distribution of engineering profession or IT operations or services or sales. And then the same goes with the geographical locations, where United States has the most number of tickets being generated, followed by India, China. Then we have the month over month ticket distribution as well across categories, and the same thing applies with subcategories. Now, talking about the actual anomaly detection view, as you can see here, the user has the capability of selecting the category as well as the respective subcategory. So right now, I have selected application and service category, and this is the time series signal in terms of the volume of tickets being generated on a daily level. And then the respective subcategory is configuration under application and service. So if I slice the data a little bit, yeah. So as we can see here, this data point which we are looking at right now is a Monday. Now, if we look at other Mondays, the number of tickets being generated are generally higher. But this is an anomaly, because on a Monday, the usual behavior should have been that the number of tickets should have been a bit higher, but the number of tickets being generated on this particular Monday were low, and this is a deviation from the usual seasonal behavior, and that's why it's an anomaly in the data set. Another example here is these huge spikes, where these are weekdays, but if we look at other weekdays, the volume of tickets is generally low. But this is an outlier, because the volume is exceptionally high for this specific subcategory, which is configuration. So this really gives insights that the agents and service engineers need to look into what all incidents are being created under configuration, so that they are able to understand what are the trending issues and how they can proactively work towards resolving these issues as soon as possible. And another thing which I like to show here is the drill down section, where we have the original time series signal, and then here are the decomposed components, where this is the trend component, this is the seasonal component, and this is the point of interest, where this is the residual component, and these two are the boundary conditions, which are essentially the 3 times of standard deviation in both the directions about mean. And wherever the wherever the residual component exceeds the threshold, that data point is essentially tagged as an anomaly. So yeah, this was a quick overview of the anomaly detection framework which we have created. And as I've mentioned earlier, we have plans of expanding it further and make it more predictive, so that the actions so that the corrective actions can be much more proactive in nature. So yeah, this was a quick overview of the anomaly detection framework. Now I'll go back to Manju, and I'll hand over the control to him to talk about the other project which we have worked for global support. So Manju, over to you.
Yeah. Hey, thank you so much, Srijans. It was awesome to know how I think there's a reputations coming. Yeah, it's awesome to know that on how that anomaly detections it will help in the global support team, especially for that the persona base. I'm eagerly waiting for that the prediction model as well.
Yeah.
Yeah. So I think now I think everyone having some basic idea of artificial neural networks. So I'm before directly jumping to the use cases, we'll discuss about what is the feed forward network and then recurrent neural network with respect to the classification problems. Because we are taking one example of the NLP classification problem. So let's begins to understand what is the limitation of feed forward networks. So next slide. Yep. So now let us take an example of feed forward networks that is used for image classification. So assume that we have a trained a particular network for the classification of various image of animals. So if you feed an animal image dogs to trained models, the network identifies that image and then provides the relevant labels to that image, that is dog. And similarly, if you feed an image of elephant, it identifies that image and then provides the relevant label as well. So now if you notice that, so the new output which we generated, that is which we got as classification as elephant, there is no relation with the previous output. So can we say that the output at time t is independent to the output at time t minus 1? Yes, so we'll go with the couple of some other examples. So there is next slide. Shri? Yeah. So there is another example that we require the previous outputs to get the new output. Let us discuss one particular scenarios. So in this example that whenever we read a book, you will understand the whole meaning of a sentence only when you understand the previous words. So if I use the feed forward network here and then try to predict what is my next word in the sentence, we can't do it because the feed forward network, as you see in the above example, it will be the output of the network is independent of the previous output. So basically, we can't use the feed forward network in such cases. That is, if the sequence of information is more important to predict the next word in the sequence. So now we move forward and then think about how can we solve this particular problem. So the one of the solution is recurrent neural networks. So in the recurrent neural networks, it is the uh, uh, next slide. Yeah. So recurrent neural network, so talking about a recurrent neural network, it is a special type of artificial neural network. It's designed to recognize the pattern in the sequence of data. So if you want to understand RNN, first we need to know what is forward propagation over times. Why I'm telling the forward propagation over time is this is the fundamental what do you call that one? So this is like main functionality behind that RNN. So if you see that on the first that architecture the recurrent neural network, the X indicates the input variable, input layer, and this input may be any number of dimension, and then any number of dimension means it can be any number of features. So the next H is indicates the hidden layers. So here we have any number of hidden neurons. So the third one is the finally we have that output layers that is indicating with the O. Along with this particular output, we will also get the output with respect to time. This can be fed as an input to the next hidden layers. So that is how the sequence of information will be stored in the recurrent neural networks. So once you unfold the general architecture, that's how it looks. So for example, whenever you're reading a sentence from left to right, say some first word x at times t minus 1, feed into the hidden layer of the neural network, then we'll try to predict what is the output of that terms at the particular times that's t minus 1. So then the next timestamp at t, so we have the next word from the sentence and then feed to the networks along with the information from the previous timestamp, that is t minus 1, to get the output of times t. Similarly, when you predict the output as time t plus 1, it gets the information not only from x of t plus 1, but it also takes the information from x of t and as well as x of t minus 1. So one thing you can see, we can observe here that on the weakness of RNN is that whenever we want to make a prediction, it uses the input information from earlier in the sequence, but not the information later in the sequence. For example, take an example that one. So his example, he said Teddy Roosevelt was a great president. So in order to decide whether or not Teddy is a part that represents the name of the person, because the sentence could also be the Teddy bear or in sales. These are the two different sentences. The meaning of the fourth word is completely different. So if you're given this kind of first three word, it is very difficult to identify that on that Teddy is a part of person names. To overcome this kind of problems, we'll use the bidirectional recurrent neural networks. The bidirectional recurrent neural network uses the concept of back propagation, that is train the model in the both directions. So when we use back propagation, you needs to calculate the error, which is nothing but actual output, which is we already know that, and then minus to the model output. And then one more important thing about back propagation is the weight can be updated only in the back propagations. So the limitation of the bidirectional LSTM is the vanishing gradient and the exploding gradients. So the recurrent neural network, it will be work good only if if you have the sentence has very less word. So for example, if let us understand the issue with the recurrent neural networks. Next slide. Uh, yeah, yeah, thank you. So let us understand the issue with the recurrent neural network. Consider one example. We have a long sentence like I went to France, and then it followed with hundreds of words, and then the sentence continues like that. Few of them speak dash. So I want to predict the what title comes after few of them speak. So if you want to identify that what is the next word, we require that what is the context behind that on the sentence which we are talking. So in these cases, whenever the recurrent neural network, the sequence if it is increasing, the iterations to come back and then understand the context, it will lose. So this is the major drawback of recurrent neural networks. Similarly, so whenever the updation will be happens to that weight, so it is very small, and the new weight is almost equal to the same weight. So this is called vanishing gradient problems. And this similarly to the exploding gradient, it is just opposite of the vanishing gradient problems. So Shri, next slide. Yeah, so next slide. Yeah.
Yep. Is the
Yeah.
latest slide visible, Manju?
Yes. Yeah,
Yeah.
can you
Okay.
go to the next slide? Yeah.
Okay. Exploding gradient or the next one?
Next one. Yeah. Yeah. So to work on the drawback of this problem, the LSTM we will use is nothing but long-term short memory. This is a special type of RNNs, and this RNN is capable of learning the long-term dependency. If you see in the Google some example, whenever you type a few word, so automatically it will be predicted what is my next word. And then we have some example like text generations things that one. And then we have the translation of English to other languages. So here in this all the example, the sequence is very important. We need to keep track of what is the context we are talking. So in these cases, we have this special type of neural network we will use, that is LSTM. So if you notice in LSTM also having the chain-like structures, but repeating model has a different structure. That is, instead of having a single network layer, it has a four layer interacting in a special way. The key advantages of LSTM is the cell state, that is horizontal line running on the top of the diagrams. So here I will explain the briefly with high level that on what are the three major steps we have in that in LSTMs. In the first step in the LSTM is to identify those information that are not required and then will be thrown away from the cell state. This kind of decision is made by sigmoid layers called the forward gate layers. Then in the second step, which is to decide that what new information we are going to store in the cell state. So this whole process comprises the following step. That is, the sigmoid layer called the input gate layer decide which value will be updated. And the next, the tanh layers, it creates the vector of the new candidate values that could be added to the state. So in the third state, what we'll do is we'll update the old state of the old state to the new state. So can you go to next slide? So here's the one of the use case which we worked on, that is the predictive intelligence for automatic global suppose ticket routing. That is identifying which this particular ticket belongs to which category and the subcategories. So next slide. Yeah. So this is the as is process. So the as is process. As Srijan explained initially that on the user can raise a ticket on one of the platform, that is Connect Me Bot. He can use and then CSVO web and then MSW and then Jensen's tool. So once the user raises a ticket, the agent redirects these tickets to respect to assignment group, and then he will add the short description based on the description provided by the user, and then he will add some more information, that is the channel information. This is like that on the is a chat or web or is a phone kind of things. And then the actual technicians validate if the ticket is assigned is correctly or not. If not, he will redirect, and then he will manually add category and then subcategories, and then he will add the closing note of the tickets. So currently more than thousands to 2000 tickets are being raised per day, and the number is continuously rising owing work from home scenarios due to the COVID-19. So majority of these steps, the current process is involves the routing of tickets to snow agents requires the manual intervention. Hence, the possibility of misrouting of ticket and then reduce the efficiency and then propagation of human-induced errors to further steps to ticket life cycle affecting the time to resolutions. Next. Yeah, the objective of this use case is to automate the process of assigning category and then subcategories to the ticket based on the short descriptions of the tickets. The here the problem statement, as you already know that one, the current assignment process is very manual, which consumes a lot of time and then has no consistency because of manual effort. And next, the problem statement is that the service engines teams wants to automate the process of assigning relevant category and the subcategory at the ticket whenever we create that in the starting phase only. The analytical approach here we took here is to solve this particular problems. The prediction model was built and then trained to predict the category and the subcategory of the ticket based on the historical snow incident data. And then we leverage the deep learning neural network solutions to predict the category and the subcategory. We'll talk about a little bit in depth about how why we went for neural network and why not machine learning algorithms. So the overall impact of this particular use case is consistent and then accurate category and then subcategory assignment in the timely manners to reduce the human induced errors. And then agent can spend very less time to resolving the ticket. And the cost of uh, solving that particular ticket, it overall time automatically will be decreased. Yeah. So this is the major impact of that one. So this is the some sample data that one. We can see that there is a short description and then categories. These are the sample data that one. And then on the left hand side that one, we can see the category and the number of tickets. This is we use for testing purpose. So they here the currently we have done nearly 13 categories. So it is same as the subcategory also. So here we have the nearly 50 subcategory. There is a sample data as well as the respective count. Yeah, can we go next? Yeah. So the methodology we use is bidirectional LSTM deep learning technique was leveraged to create an intelligent prediction model to predict the category and then subcategory. So basically how it will work. So majorly we have 5 phases. So data extraction, text pre-processing, training data preparation, modeling, and then predictions. So we'll discuss one by one. So in the data extraction, the historical snow incident data was collected for the analysis and the fields such as the incident number, short description, category, and then subcategory were extracted. So there are approximately nearly 15 category and then close to 50 subcategory information as there. So we have done some root cause analysis with respect to the raw data. And then couple of observation what we saw in that raw data is that the first observation is the duplicates data. That is nearly in the production system we have 5 millions of records. But if I saw that duplication, there is a nearly 2 millions of record as a duplication record. So we can't directly use as is data for that on training that model. So this can be leads the more unbalanced data. So there is the one. And the second observation what we saw is the same short description data was present in the different category. For example, the short description A present in the category X and then Y also. So this will lead this kind of data will leads the misguiding the model for training. So we need to eliminate those data in the pre-processing technique only. The third observation what we saw is the miscellaneous categories such as others. So we need to, whenever you do the classification problem, first we need to identify that on identify this any miscellaneous categories are there or not. So here in the category and the subcategories we see that others. So then it will not be good that you can add this kind of category as a for prediction kind of thing. It will not give any value to that any customer or anyone that one. So another the fourth observation is the generic categories. So it is very important that whenever you do the category things that first check that on any generic category it is already there or not. For example, there's the inquiry and the help. So most of the data that is present in the inquiry help can be belongs to any other categories like network, account, or application kind of thing. So while training that models, we'll give the less weightage to the this particular category to improve that performance. So the fifth observations. So empty and then non-readable textual information in the chart descriptions fields. So it is good to eliminate such record in the pre-processing technique only. So this is with respect to data extraction step. Then we need a then what are the observation what we saw that is we need to taken care of everything in the test pre-process technique. So here in the test pre-processing technique, what we have done is the transferring this short description text of an incident for efficient knowledge discovery by using the techniques such as stemming, lemmatization, rearranging stopwords, and the regular expression. In the stemming, what it will happen, the word are reduced to their word stems, not necessarily be the same dictionary based root, such as removing the suffix and then prefix information, that is ed and then ing. For example, that we have a word like resolve, resolving, and the resolve, it will be mapped into that one resolve. This is only one word that one. So these are the things will be taken care in the stemming pre-process technique. And then next is lemmatization. So here what we do is we are mapping the words to the dictionary based on morphological root, we'll call as a lemma. So we are so if you see that in most of the ML or deep learning techniques, we'll use only stemming, lemmatization, stopword removals, but we added regular expression is another layer to make sure that data is clean. That one. So here, what is the reason we use the regular expression is that we observe that in the root code whenever we see that data raw data that we observe there is some Chinese characters are there, and then Japanese character is also there, and then there is a suffix with q/a and then n/a and a couple of symbols which will not give any value to the sentence. So those are the things we'll handle in the regular expression. So these are the four techniques we use in the pre-processing things. The next step is data preparation for the models. So as we know, the machine understand only numerical values, and to use any algorithm, data is to be converted in the machine reliable format, and hence the data is processed in a ways to get binary vectors. So we use here as tokenizers to break the sentence into the words, and then one not encodings for representing the word as a binary vectors. So the next step is that is important step is training and then validation of models. So here we have done that we experimented with different models. So here we use it Azure Auto MLs. I think previous session we saw that on Azure Auto ML, and then we use some couple of machine learning based algorithm, and then in the recurrent neural network also we use that RNN bidirectional bidirectional RNN and the LSTM, and then as well as bidirectional LSTMs. So after comparative study, the bidirectional models with a exogenous parameter was finalized using the F1 score as a performance matrix. Before I'm going to the neural network, I will give one the whenever we use algorithms like machine learning classification algorithm in machine learning and then auto MLs, so we got accuracies like only 65%, because you can see the reason behind that the data is not like, if you read also, if you in the example, if you read those data, you're not able to understand few of the, because it is not the actual data what else the user is sent. This is a short description, description data. So it is sometimes it is difficult to understand in the machine learning problem, and then we required we need to keep track of that on the sequence. The sequence also is very important. If you go in any like normal machine learning algorithm, whenever you doing the word embedding things like bag of forward and the TF-IDF and the word to vector, what will happen that whenever the particular sentence up to some sequence, it will be it will have the context information. After that, once we use that word embedding, all those things, it will be each word, it will become an independent component. So you know that already in backup words, and what is the disadvantages, advantages, why we are going with the TF-IDF, and then some disadvantages in the TF-IDF also is we have that. Then we are moving to the word to vec that. Those are the word embedding techniques that one. So here that hyperparameters we use for LSTM is that one. So we have that one embedding layers 128 embedding layers we use, and then LSTM layer, the input layers which we use for LSTM is 256, and the batch size is 16k. We use that one. This completely the batch size is completely depend upon the which ADB cluster we are using for the computational purpose, and the number of epoch based on the experiment result. The 200 was the best things that also it will not be, the model shouldn't be overfit kind of things. And then we use that last function as a categorical cross entropy. So the reason for the categorical cross entropy is that whatever we are handling, that is like multi-text problem. It's not a binary classifications. So that activations for the output layer, here we are using the sort max. So the totally, if I see that on the LSTM, the parameters, the default parameters which we use for the training this model is like 13 crore. That is the default parameters we use that one. And then it took nearly 4 days to train that completely models. It is in production things. So the reason is the 4 days is that on the data, what is the quality of the quantity of data we have, quality of data we have, that one is like nearly, I think 3 millions of record, 3 millions plus we have that one, and then it just keep on increasing that one. So currently we schedule as a monthly basis that one. So we are working on the feedback loop that one. So one major thing that whenever you doing any ML algorithm or deep learning algorithms, better to have that on a feedback loop that one. So because in that day, because we have the already we have the computation power, is it will taking a huge amount of time, and then we can't do that like a daily level. We can't schedule for neural networks. And then in the feedback loop that one, you can that user can have options to overriding the predicted category and then a subcategory if the prediction is incorrect. Through this, through this that the model can be retrained itself to improve the accuracy further. Because any ML or deep learning models, what is the training data set, what is we use initially, it will not be the same as the futures. The model can be work for up to another 1 week or 10 days, 10 days or 1 month. That after that, again it will be the data can be in the source. It can be the new unseen data can become. So to avoid those things, is better to have the feedback loop. So the next one is once the training that model is done, so we deploying as a web services. So the use of the web services is that one already, I think Aditya has covered in the previous. I will not go in depth that one. So here we are using in the, we are using is that the agent enter this short description of the tickets on the agent 360 portal. The portal, then it will be using that portals we call directly will hit into that web APIs, and then we get the actual category and then subcategory information at the real times. So the current model, that accuracy was like 95%, which is for category informations which we have that on currently. That is this model is already in production as of now. So next slide. Shri. Yeah, so this is the production model, which the accuracy for the 200 epochs, that is nearly 96%. You can see that you can see accuracy, training accuracy and the validation accuracy. So here that validation accuracy, you can see that one is little bit constant kind of thing, 85 kind of things that was. So here the when we do the training things that the we one of the parameters we not able to we forgot to modify, that is the shuffling things. So we know that on only training and that testing a data set. So here within a training we have that on again we have that information like training data set and the validation data set. Here the validation data set we forgot to do the shuffling. What is happening is whenever it will be retrained one more time, the same data will be the same data will be retraining. So now we have modified as a shuffling as is true, so that I think maybe in the next run that one we can have that on good accuracy for that validation also. Yes. So next slides. So this is the confusion matrix that one. So which with respect to actual and then a predicted category things that one. So we can see that one there is a blue line that one. So nearly that application services, that is 96 percentage. It will be properly identifying. These are all are unseen data. The test split what has initially we done that one. So we after the training of that model, we use that unseen data, and then we calculate what is the confusion matrix. Yeah. So next slide. Sri. Yeah. So you can see that on all the precision and the recall and F1 score for each category levels. So here in most of the times, because initially in ML, whenever we do that, we'll thinking about only accuracy things. But in some cases, the precision and recall is also make. This is based on the use cases, we'll decide which one we will take that on. So here maximums we will take as a F1 score as the accuracy to decide which model can we take that on. So this is the F1 score details for each category things. Yeah. So Shane, next slide. Yeah, so I think model deployment, I think morning, I think Srijan is already covered, and then Aditya also added, I think he also explained more things. So I think we no need to go one more time, model deployment things that one. So that's all from our side. If any questions, you can you can start asking.
Thanks, Manya. Thanks, Trijan. So if anybody has any questions, so please do come out of the mute, or if not, you can post it into the chat. If there are any suggestions, feedback, even for the future sessions,
Yep.
Please do share it in the chat, or like I said, you can come out of the mute and also, yeah, share the feedback.
And thank you, Aditya, Manjunath, Srijan, and Sanchita for your time, right, and spending the weekend and presenting the session today. It was very insightful, and I hope everybody is benefited out of it.
Thanks, Abhijit. It's our pleasure.
Yeah, thank you so much.
So, any question from anyone, right?
Yes, Ramakrishna. Yes, you will get the recording. We'll post in a day or two into the upload into the YouTube, and we'll share the link both in the Facebook page and as well as the our LinkedIn page. Okay, so
Can you share the LinkedIn page here in the chat,
yes,
right? As
so
we have
just
recently created
give
that.
me
Yeah.
1 second. Probably I would actually go ahead and share the links.
Yep.
So that everybody is aware of the links.
Yeah. Yeah, we are pretty much active on that Facebook page, right? And steadily we are trying to get some more engagement on the LinkedIn as we see the people are more active there. So do follow the pages for upcoming events or anything that we are organizing. And any event announcement you see and anyone interested to even deliver a session, please reach out to me or Shravan or anyone from the user group members. There is a couple of questions. Maybe Manjunath or Srijan, you can take a look.
Yeah, sure.
Yeah, or Aditya, right? Yeah.
Okay, so what is the effect of parameters like precision recall and FS score and then performance of the models? So anywhere you want to take that question, Sri?
I guess you can go ahead, Manjunath. I guess so F1 score and precision and recall do not have any effect on the performance of the model. They are more about assessing how the model is actually performing in terms of the accuracy metrics. So in real time scenario, it does not affect the model. It's all about assessing how well the model will perform in real time scenario. Just feel free to add on to what I said, Manju.
Yes. So I think whatever you said that is true. And then a few things on whenever we consider precision recalls is based on the what kind of use cases we are handling. For example, some use cases if you are doing the cancer detection, so there we will will think out more that more about that false negative things that one. So they that accuracy will not be will not consider. So we'll consider as a precision is a more priority there. So based on the use cases we'll choose our what was the model we are building that it is best suitable for these use cases or not kind of thing. So it's completely depend on the use cases, if it is a medical field and what kind of criticality of the predictions we are doing that one.
All right, so this is our Facebook page link, and this is our LinkedIn new LinkedIn page. So whichever you are more interested, please do use the pages, and this is my email ID. So if anybody is interested in presenting any future sessions, or if there is any feedback, please do reach out to me, or you can reach out to Abhijit on the Twitter directly. So with that, so thanks to all the speakers for presenting a wonderful session. Right. And thanks everyone for joining on a Saturday. All right, let's close the session, Abhijit.
Yeah, okay. Thank you so much, right? And have a good rest of the day, guys. Thank
Right,
you. We
thanks,
look forward
guys.
to meet you in the upcoming events. Okay. Thank you so
Yeah,
much. Bye bye.
yeah.
Thank
Thank
you.
you so much for all.
Thank you, sir. Thank you,